Okay, let's get started. My name is Bill Fisher, and I'm a software engineer at Facebook. Can everybody hear me okay? Okay, great. Today I'm talking about React and Flux. React and Flux are two technologies that we use at Facebook to build web applications. And they go hand in hand. We've built everything from small little widgets to gigantic revenue-critical applications with React and Flux, and it has scaled to everything that we've thrown at it. And we've had a lot of good luck with it, and that's why we wanted to share it with the open source community. So just a couple of housekeeping items to start off with. These slides are available on Speaker Deck. And there are a couple of websites for both React and Flux in case you're looking for additional documentation or additional example code. Here's a couple of hashtags that you can use on Facebook or another social network of your choosing. They work on lots of social networks. So to start off, I want to talk about something that happened to me one day earlier, I guess at the very beginning of the year. I was sitting on my couch at home, and a friend of mine, Rob, sent me an IM. And he said, I'm really excited about React. It sounds really cool, but I don't really know how to get started. It's just the view layer in the MVC, right? So how do I get started? Exactly. And I thought about that, and I thought about what I could tell him. And I thought about, like, yeah, you could plug it into Backbone, or you could plug it into some other framework, but that would be so awful. It wouldn't really be taking true advantage of what React can do and the way that we use it at Facebook. And so I told him about Flux. When I thought about his MVC situation, I thought about, I really don't want you to go down that path that you're going to go down of having a bunch of models that eventually, where one model is going to have a piece of data that another model needs. And that's going to create a dependency between these two models. It's like one model is going to hold some application-wide, very important piece of data, and the other model is going to need that so that it can derive a value from that piece of data. And that's going to make that second model a second-class citizen. And we're going to have to make sure that when that first model updates first, and the second model updates second. We're going to have to keep that organized, and we're going to have to keep that in our heads. Unfortunately, in MVC, this is a pattern that tends to propagate. And suddenly you have a lot of models that you're having to make sure they update second. And then you have another piece of data in a different model that some other models need to know about. And now you've got a lot of data flowing in a lot of different directions. And you have to keep it all straight in your head, and you have to manage it. Has anybody seen this situation? Yeah, right? OK, cascading updates across models. Not a pleasant situation. But it doesn't really stop there, because your product manager or your client or whoever it is comes in and they've got a great new idea. They're going to pivot the product, and it's going to grow. And it's going to grow some more. And you've got views also connected to these models, maybe with two-way data bindings. Hey! And now all of a sudden, you've got a very bad situation where maybe you have no single source of truth anymore. And you've got a lot of connections going on all over the application. And this is not a fun situation. Some people solve this through PubSub. And they say, well, we're just going to have everybody just emit events, and then whoever needs to deal with it, they will. We won't have any connections. It'll just be like radio broadcasts. And that's cool until you need to make sure that those events are arriving in a certain order. And those updates, again, are happening in a certain order. Or maybe you are new to the application and you break it open and you're looking about, oh, wow, we received data here in this module. Where is it coming from? I don't know. So that's not a great situation either. I call that spaghetti code. But there is a way out of this situation. And that's by adopting some constraints. The constraint we've adopted with Flux is a unidirectional data flow. And it's amazing how this has cleaned up our code at Facebook. Things tend to naturally fall into place when we use this pattern. At the top of the flow, there is an action. This is where all data originates. That data goes through a dispatcher where it's given to all the stores. Stores are somewhat like models, and I'll talk about the differences between stores and models in a little bit. At that point, the stores update themselves according to their own rules. And then the views that are listening to those stores receive an event from those stores. The stores are just saying, I've changed, so deal with it. And the views then query the stores for the data they need, and they update themselves. The data flows in a single direction. So this is the plan for today. We're going to talk about the anatomy of a React and Flux application. I'll walk through the data flow, hitting each part of the application. I'll talk about the actions and the action creators. We'll talk about the dispatcher, the stores, and I'll talk about how to test stores. We'll get to the views, the controller views, and how React works toward the end. And at the very end, I'll talk about how to initialize the application and how to work with a web API. But first, let's talk about how the application gets structured. There are really kind of two types of files. There are the primary files, which map to that data flow diagram that I just showed you. And there are some secondary files, like the bootstrap, the utilities, some constants or some configurations. And these are also in your application, but they aren't the core data flow. So here's what it might look like, even including the CSS and the index.html. Package.json's down there to pick up some modules, some NPM. But really, we're worried today about the JavaScript, so let's focus on that. So what we have here are, you can see at the top, we've got the actions, and then we've got the dispatcher, the stores, and the views. And you can see at the bottom, those views are React components. It's convenient that this is alphabetical. So let's take a look first at the actions. The actions are an object with a type property and some new data. This is how all data enters the system. It's important to keep that in mind. Action creators, on the other hand, are methods that create actions. They're semantically named, collected together in a module, and those become the API for our application. Any part of the application, typically the views, that needs to create an action will use that to launch that action off and send it to the dispatcher. Here's what the action creators look like. We're really focused here on this create message method. That is an action creator method. And you can imagine a file with like 15 of these things in it and maybe 6 of these files. So you can imagine there's maybe a lot of these in a large application. This is how it's structured. We have a call to dispatch. Our app dispatcher has a dispatch method on it. And we're going to send that object through there. It has a type that we're giving it a constant here. It's probably just a string under the hood. And some text. We're going to create a message. And we'll give it that name, that semantic name, so that when we're programming later, it has a nice, like, readable, phrase that, like, kind of like works in the code. It becomes a bit of a DSL. So now let's take a look at the dispatcher. The dispatcher is really simple. It's really like as dumb as a rock, actually. It has no intelligence of its own. It's just a registry of callbacks. That's all it is. And, but it helps us organize the code together, and we can utilize it to do what we want. So basically, when a dispatch happens, the dispatcher just calls all the callbacks in its registry and invokes those callbacks. And those callbacks have been registered by the stores. So in Flux, a dispatcher is a singleton, and the payload is an action. But the dispatcher is a completely abstract component that you could theoretically use in a different context. Its primary API are these 3 methods, although it has a few more. These are the ones that we'll most often see, though. Dispatch, we already saw in the action creators. Register and wait for are 2 methods that will be used by the stores. And you can get this dispatcher. This is the same dispatcher that we use in production at Facebook, and you can get this on NPM today. It's also available through Bower. So we want to just create a singleton out of this class and give it our own name, just in case there might be, by accident or by design, another dispatcher on the page. So we need to have a specific dispatcher that we know is all of our own. So next, let's talk about the stores. This is where things get a lot more interesting. Stores are great. Each store is a singleton, and it is essentially the locus of control in the application. Nothing can touch the store. Nothing can get inside of it. It's the only way into the store is through the callback that it registers with the dispatcher. It's going to manage application state for a logical domain. Now, what a logical domain is. In an application, you might carve up the application not according to necessarily like ORM models, like you might do in a backbone collection, for example. You want to carve up the application according to like logical relationships. So, for example, you might have, I'm working on an application right now where I have a friend store. So everything related to friends and all the logic that's related to friends is in that store. We also have an image store where people can pick images. Okay? And all the logic related to images is there. And the selection of those images, all the images that are available to be selected. We might also have a time store. The time store might manage like the sequence of a slideshow. So there are these logical domains, and that's how you separate out your application. Because all of the logic that's related there needs to be contained together. So inside the store, you're going to have private variables that hold that application state. Those could be collections. They could be multiple collections inside of a store, or they could just be single values. Like I said, they register a callback with the dispatcher, and that's the only way in. It's a very limited way of getting any kind of input, and that's by design. Nothing can get in. There's no setters. There are only getters. You can only pull from the store. And the only other way you're going to be able to get data into the store is by firing off an action. When it gets done finishing its update of its own data, it emits an event, like I said before, and the views can get the new data. So here's some code. It's very small, but let me see what I can do about zooming in here. Yeah, so up at the top, we've got some private variables, the dispatch token, and the messages. The messages in this case are going to be a collection of messages that we create. The dispatch token is the reference that we have to this store inside of the dispatcher. Down at the bottom, you can see we have some getters that are making these private variables into protected variables. So we can get their values, but we can't change them. Any other store that needs to wait for this store to update first needs that dispatch token. So another store, when it's updating, can say wait for, and then foo store dot get dispatch token, and its update will stop at that point. It'll wait for this one to complete, and then it can continue. But what's really interesting here is the middle part, and that's the registered callback. The registered callback is basically just a gigantic switch statement. We declare in our registered callback what action types we're interested in this store. And if an action comes into the store that we're not interested in, it's a no-op. We can respond to those different action types in a way that we define in this store. And then after the update happens, then we can emit change. The important thing is here that the store is a universe onto itself. And that, excuse me, and when we preserve it like that, it becomes completely decoupled from the entire system. We could actually even theoretically take this store and pull it out and use it in a different application. All we would need is to send it actions with the same action types, and it would start updating data in just the same way that we did in the first application. So let's talk about how to test stores, because it's not really immediately obvious, given the fact that you only have this callback, how you would get data into it so that you could test its behavior. We have at Facebook another open source project called Jest. Jest is our auto-mocking test framework. So it's a lot like Jasmine because it's built on top of Jasmine. But what it does for you is any other methods that are in your tests from other objects are automatically mocked. And so they get called, but nothing really happens there. That gives us, however, a reference to the way in which they were called. And this allows us to completely cordon off the one object that we are actually trying to test. So it becomes a true unit test. So let's take a look at how we get the callback using Jest. So what we have here is this callback. And we're getting that by saying, give me, essentially, the first argument of the first call to appdispatcher.register. Every method in Jest is given this mock property that contains all this metadata of how that function was called. So what we're saying here is like, OK, we have this list of calls inside the mock object. We'll take the first call. And of that call, we want the first argument. That is the callback. So if you have this one line, then you can set up a test. You put that in before each. You get the callback. And now you can use it throughout your test suite. And it becomes essentially a setter. Down at the bottom, inside of that test, it says it can create messages. You see that we've got an action with a type and our test text. OK, so next, let's talk about the views, and we'll talk about React a bit. So React, or views of the application, are just React components. We have a tree of React components. There are certain components that are special, however. These are the controller views. We call them controller views because they pull data out of the stores and they provide them to the rest of their children. So it has this controller-like quality, but it's not really quite a controller, and it is an actual view. It does render things to the DOM. So we call them controller views. They live near the top of the application, typically, although you can put them down below. and they listen for change events. The problem with putting them down below is it's really great for encapsulation of a certain area of your application. Like you only get the data that's related to that area of your application coming into that part. But what it does is it introduces oftentimes a secondary stream of data, and that can become difficult to debug. You don't know what is actually firing off a render at that point, if it's the controller view that's up above, or if it's this deeply nested controller view. And so I've done that before, and it works, and it's good in the sense that you get that encapsulation, but there's a trade-off in that the debugging becomes a little bit more difficult. I prefer to put them at the top when I can. So, so they query the stores for the new data, and they re-render themselves and their children. Let's talk about React and how React works for a second before we move on. So React is really just a component-based system for managing DOM updates. That's really all it is. And it uses a virtual DOM, which is a data structure written in JavaScript, off to the side of the DOM, to understand what is going on in the DOM. It also has a reconciliation algorithm that allows us to make the most optimal update to the DOM in one fell swoop. We hit the DOM once, rather than a whole bunch of times for all the different parts of the application that need to get updated. Now that oftentimes means that you're updating a big portion of the page, but that's okay, because it's more efficient to do that than to hit the DOM multiple times, because the DOM is so slow. This gives us a huge performance boost. It's such a huge performance boost that a lot of people are really super excited about it, like I said. It's being used as the view layer in the OM framework. It was early adopted by the Khan Academy. Yahoo Mail is rewriting the entire mail application in React and Flux. Adobe Brackets is being rewritten in React and Flux. Atom.io, the text editor from GitHub, is written with React. And of course, it's being used all over Facebook and all over Instagram. The bonus here is that we can stop thinking about the DOM. That's a great thing. In the bad old days, we'd have to think about, oh, I've got to batch my reads and batch my writes and hit the DOM as little as possible. Now we can like stop thinking about that. And conceptually, we can think of our UI re-rendering constantly, even though it really doesn't. React's paradigm is the really super big bonus for you as a programmer, because it's really fun to program in React. It's based on functional reactive principles, and you can think of each React component as being sort of like a function in like a pure function, in a way, in the functional programming sense. Like functional programming, it's predicated on a unidirectional data flow. Props move down through the tree in a single direction. It's composable in many of the same ways. Your child components can give new behavior to their parents. And likewise, the parents can also provide behavior to their children through the props by sending a callback down through the props. It's also declarative. When you write a React component, you're basically saying, this is what the UI should look like at any given point in time, given these props. So you provide data to a React component through the props, and rendering is a function of this.props and this.state. Now, React components can contain state. They're not completely stateless. But it's best if you keep your components as stateless as possible. And this is what Flux allows. Flux allows us to get all the state out of our React components and move it to the stores. We can, like I said, we can think of re-rendering every time, and you'll see that your render function is getting called many, many, many times. You put a console log in your render function, and you'll start to freak out, and you'll think, oh, I'm hitting the DOM so much, this is terrible. But you're actually not hitting the DOM that many times, because if there's no change in output, React will intelligently not hit the DOM with that change. There is also a component lifecycle API and an update cycle API. These methods are ways in which we can hook into the components And we're going to use these methods to create our controller view. So here's the lifecycle methods off to the, I guess, your left, and the update cycle is off to your right. This is the order in which things get called. The React component starts off with get default props, moves through get initial state, component will mount, and finally render. At that point, DOM mutations are complete, and you get component did mount. And if you are blowing away this component, eventually you get component will unmount. You can provide things to do at all those points in the life cycle. On the other side, this is like when you say set state, or when the parent re-renders, or you send new props down, you get this cycle. Component will receive props only when you receive new props, does that get called? But the other ones, should component update, component will update and render, and eventually component did update happen on every render cycle. These are the 4 methods that we're going to utilize to create our controller view. So with component will mount and component will unmount, we're going to set up our event listeners. In get initial state, we'll get the initial state of the application from the store. So this is what our store is going to look like at the beginning. Excuse me, our controller view is going to look like in the beginning. We'll just start with a render function, which is the one required function in a React component. We'll save that for a little while. First, we'll do our event listeners in these 2 lifecycle methods. When change happens, there's going to be an event listener that gets called. We'll have to define that down at the bottom on change. We'll call set state to put the message's data into the state variable. And that will force a re-render. It's very similar to what's happening in get initial state when this component first mounts. Both of these things are getting data from the store and rendering with it. So those are the same for lifecycle methods. So let's talk about rendering. And here's the most controversial part of React. We like to use this thing called JSX in our React components. JSX is a way that we can write XML-like syntax inside of our React components. And this, of course, requires a pre-compilation step. So this, and when it was initially released, raised all kinds of hairs on the back of people's neck. People didn't want to deal with this at all. But it actually turns out to be a really nice declarative way of defining how your component should look. Cognitively, you can think of it very similar in a very similar way to the way your HTML actually winds up getting created. We can use variables in here as well. And so what we'll do is we'll provide an array of children for this unordered list. And let's go ahead and define that array. We'll pull the messages out of this .state. We'll map over them. Each message will then create a child component. And now we have an array of children. You can see that I'm providing the 2 props that it needs, ID and text, plus a third one, which is the key. Anytime that you have a list of React components that's created in an array like this, you need to provide a key as one of the props. This helps the virtual DOM understand what's going on in one of these lists. It's just a little helper that you provide to the virtual DOM. And you get a little error if you forget. So down here in the child, it's pretty simple, but this time I am receiving props into this component. In the controller view, I didn't receive any props. This time I am, so I'm going to define some prop types. This gives us type checking for a React component. I can say these two properties are required, and they have to be of these types. React prop types are pretty great because there are some very advanced ones, like say you want to pass an entire object as one of your props. You can use certain things like a shape which allows you to just say, well, I need the first thing has to be a string, and the second thing has to be a number, and the third, and the one after that is an array. And you can essentially kind of describe what the contents of an object are. And that's basically it. this is how to create a React component. So let's talk about initialization of the app at this point, because there's a lot of different ways to do this. I'll talk about the way I'm doing it now. So basically, you do this in the dispatch in the Bootstrap module, and the goal here is to initialize the stores with the data that you have coming down with the page load before React renders. Now, there's a couple of different ways you can approach this. You can just build your React components so that they can take a null value and sort of just like kind of gracefully say, oh, whatever, I'll just wait a little while until the real data arrives. But the way I like to do it these days is to use that, to use the dispatcher and add a registered callback to the dispatcher in the Bootstrap file. You can say, OK, now I'm going to require all the stores into the Bootstrap and say, OK, now we're going to wait for all the stores to update using the wait for method. Wait for them all to update first, then I'll render. So that's the way I'm doing it these days. And then working with a web API. This has been something that a lot of people have gotten tripped up on, in terms like people that I've been trying to work with on like Stack Overflow or the React group on the Google groups. It doesn't really matter where data exits the system in Flux. What really matters is just where data enters the system. So you can call out to, usually you put all the XHR related stuff in a single utility module, like a web API utils module to encapsulate that XHR stuff. And sometimes you can call directly out of your action creators to your web API. Or maybe sometimes you want that data to go all the way through to your stores where you might do some validation work. And then you want to call the API. That's fine. Wherever you want to do it, that's cool. But what matters most is that when that success or error callback comes back, you need to create an action so that the data flow is intact. Like I said at the beginning, all new data needs to start with the actions. It's very tempting to say, well, I'm in the store already. I'll just handle it directly. That leads you to a world of hurt. And it makes your application brittle because now suddenly you have all this logic for handling that success or error callback down in one store. And when the new feature arrives that needs to work with that same XHR call in a different store, you can't handle it. So the goal there is to go through the actions. Now your application is resilient to change. So just to wrap up here about where Flux fits into the larger ecosystem of application architectures, Flux and React. It's obviously similar to functional programming and functional reactive programming. It's very influenced by those things. It also has similarities to what's called data flow programming, in that the store has this very limited input and output. And this is a value that data flow programmers have. It's also obviously, you think a lot about data flow when you're writing a Flux app. It has some similarities to MVC, but I don't think it's quite as many as the similarities that it has to CQRS. I mean, there is, of course, the split between the data layer and the view layer. But that's kind of where the similarity ends. The CQRS, on the other hand, that stands for Command Query Responsibility Segregation. You have a command that goes out to the data layer, similar to an action in Flux. And that data layer does some work, and then the view queries for that data again, just like we do in Flux. So it's very similar in that way. CQRS, on the other hand, reifies those things a bit more, the command and the query, more than we do in Flux. And so I wouldn't say that it's exactly the same, but it is very, very similar. But with all this like alphabet soup, the three letters that you really need to remember is F2W. Flux totally works. And that's about it. That's all I have for today. I would love to take some questions. Yes?
All right, so let's say you wanted, specifically talking about in your views, you wanted to use something, a widget like select to or something. How would you integrate that? into
Select to, what do you mean?
like select to is like let's say you want to use some jQuery widget or something on your HTML. Something simple like that. How would you then trigger that to?
On the DOM, okay. So in those lifecycle methods, the question was, let's say I want to use something from a third-party API that actually directly manipulates the DOM. How do I integrate that with React and Flux? In those lifecycle methods, in the layer at which we have mounted, that is the ones that happen right after render, you have access at that point to the DOM node that is present for that moment in time, then the current state of that DOM node. Okay? It's the exact API call is escaping me at the moment, but I think it's like this dot get DOM node or something like that.
Okay.
Yes, question.
So I recently converted a React app to use Flux architecture, and I have a question about how to update stores that depend on other stores.
Okay.
So like one obvious way of doing that would be to subscribe the store that depends on the other store to the way that you would subscribe a component. Are there other ways of doing that or better ways of having a store update when another store updates?
So all of your stores are going to receive that same action together. So I'm sorry, the question, everybody heard the question? She has a microphone, so, okay, great. So all of the stores are going to receive that same action. So what you can do is, in the store that is the dependent store, is that you use the wait for method from the dispatcher. You just simply say wait for, and then use the dispatch token from that other store that you need the data from. And at that point, you can use the store's getters to get the data that you need.
So would that code go in your in the big switch statement then?
Yes, or you can always, of course, like wrap it up into a private method and have it in the store. But yes, basically, it would happen in the switch statement in response to that same action.
Okay, thanks.
Yeah, sure, no problem. Yeah, right here. Oh, I'll get to you next.
How do you handle high-performance animations that require something like touch move on an element and then change the style in a request animation frame?
Okay. So how do you handle like animations or things like touch move that are happening super fast? First of all, ideally, you would use request animation frame, right, to throttle that down, because you don't want to be faster than the refresh rate of the page. So what I would do typically is, if I was having a problem, first I would detect that I'm having a problem, right? And then I would say, if I'm having a problem, in the event handler for the touch move, I would put it inside of a request animation frame and then fire the action. Does that make sense?
You would fire the action to update the style tag of maybe moving something around as an action, opposed to just changing the...
Yeah, I mean, it depends on what you want to do in response to that touch move. If you want to update the style tag, that might be a good place to have state in the component. Okay? If it doesn't really relate to anything outside of the component, and if it doesn't, doesn't really need to be application state, it really needs to be component state, that is actually a good reason to use state. And I should mention, like, input elements are a really important place to use state in the component. Like when you need to have a managed input component in React, which is available, like if there's more documentation on this on the forms in React page, that's a really good place to use state in a component. Okay, yeah.
Hi, I'm building a new application with Flux and React, and so far it's awesome. It's working really well, but I tried out a few different ways to implement Flux, and I eventually ended up on Fluxor, which is third-party library, I guess. So what's your opinion on different libraries implementing Flux in different ways? Are they overkill compared to the Facebook dispatcher, or?
I think you need to find something that suits your style. The style that we have at Facebook is not as terse as some of the frameworks. And I think that terseness matters. So I think that if you're looking for something that's more terse than what we've done, you should go with somebody else. I do get just a little bit concerned when people start really tweaking Flux into something that really isn't it. And as long as they're upfront about that, that's cool too. Maybe it works. We just don't know that for sure at Facebook, and it's hard for us to say, yes, this framework is great, when we haven't really tested it. So there is a lot of different ones. Fluxor is a good one. That's pretty true to the original implementation. Another one is Fluxy, which uses immutable data, which I think is a great thing. I didn't really talk about why immutable data is a great thing, but maybe I could touch on that briefly if we have time. What time am I over here? 2:20? Yeah? OK. So immutable data in the lifecycle methods, in the should component, I think it's should component update is the name of the method. Inside that method, you can set up a test of like, is the new data, are the new props any different from the old props? Or is the new state any different from the old state? And you can do that just with a triple equals if you have immutable data. And it becomes very simple to set up this test, right? Because it's just the same reference in memory at that point. So you can set that up, and that short circuits the entire rendering process and the virtual DOM check for reconciliation. The virtual DOM immediately says, OK, I don't need to update this, and anything below it, because nothing has changed. And this can optimize React even further beyond the kind of performance that you're having just by using it. This is like a uber optimization over and above. Okay? So anyway, that's why immutable data is great, and Fluxy does that. There's a couple others that seem to be fairly good implementations. There's a lot of excitement around Reflux, but Reflux does away with the dispatcher and implements that whole process very differently. And that's the one that I'm just like, I have no idea if that scales. I have no idea. But maybe it does, and if it does, it's totally cool.
Sure, thanks.
Yeah. I'll take this one at the mic, and then somebody else.
Hi, thanks. I was wondering how you would recommend handling errors in Flux, and especially do you represent errors somehow in the store, or where do you do that?
Yeah, so errors, so let's say you have a validation error. Is that the kind of error you'd like to think about, or maybe like an API call error?
Yeah, either.
OK. Well, a validation error is relatively easy because what you can do is you can set up an error state, right? And let the views know through the normal processes that the error state has changed. And you can give the error like metadata and things like that. With an API call that you're trying to respond to a situation where you've done a optimistic rendering, and you're trying to now like backpedal that optimistic rendering after an error, that's a lot more complicated. And for that, you need kind of like a difference between client IDs and server IDs, and you need a process for reconciling those two things. This is a little bit beyond the scope of this talk, probably, but there is definitely a bit more work to do around handling that kind of thing. Yeah.
Thanks.
Yeah.
Can you comment on the feasibility of using Flux without React, specifically web components?
Sure. That's a cool idea, and certainly there's no reason why you couldn't do that. The only problem that you would have, I think, in that situation is that Flux is assuming that your view layer can simply handle the kind of like updates that it's going to be providing. Like, for example, you might have 3 or 4 stores or more that are all changing simultaneously. And they're all going to emit change. And everybody that's listening to that is going to like need to re-render themselves. Now, React handles that super gracefully. Web components, probably not so much. But the fact that there is no reason why you can't use something else other than React. It's true. Yeah. Yeah.
So, what's the stage? Is there a seed project for Flux?
Was there a seed project?
Is there one? Like a template?
Is there a template?
Yeah, like a template.
There's a couple of examples in the GitHub repository.
My main question is, are those scalable? Is it like if you're building, like basic for building your app, or do you need to do more?
Sure. I mean, yeah, I think that those are examples that you can use and you can base off of like what to do. They aren't perfect. I won't say that they're perfect. There's also other examples. You know, Yahoo has examples also on their GitHub account for what they're doing. It's not just Yahoo Mail that's adopted React and Flux. It's actually numerous related properties that sort of surround Mail, like I think Calendar also. And so they're doing a lot of stuff on GitHub that you can take a look at. They're really into the isomorphic thing, like they render on the server with Node, and they with React, and then they send it down, and then it kind of dissolves into a React and Flux application on the client, which is totally cool, right? So that's some other examples that you could take a look at. On how to start building one? Well, the way I would do it, because I do this at work, is that I would basically just get the dispatcher off of NPM. I'd get event emitter off of NPM, and I would get Browserify to start doing my compilation steps, and I would start using those tools. And that's basically the examples that we've put out on the Flux repo. They're built like that. You need to be running Browserify to compile and all that kind of stuff. So that allows you also to use things like ES6 and other goodies. I mean, compilation is a nice thing. It helps us move the web forward. Yeah. I think that I'm out of time, but I'm totally open to taking some more questions out in the hall or something like that. Thanks, everybody. I really appreciate it.